Yes, interpreter versus compiler. Yes, how interpreter working, how compiler working. See, interpreter and compiler both are converting from high level language to machine language, but the way of working is different. Interpreter and compiler, interpreter and compiler both are to convert from high level language to machine language, but the way it's working is different. The way it's working is different. Let us see interpreter and compiler. Okay, for interpreter, just I'm taking Python. For compiler, C language. Compiler C language. So first let us start with the interpreter. How interpreter working here? Interpreter. Suppose some Python source code. Python source code. Python source code. Yes. Maybe test.py. Python source code file. Test.py. Python source code. Python D drive. Yes, mn Python folder. In this Python script is available. Some test script is available. Test script. Yes, open notepad. See, this is Python script. How this Python script is working? Let us see. For this CMD, go to command prompt, D:, D drive. In D drive, dir check for the contents. Dir the disk contents. Okay. Yes. Here they say test. Yes, here this directory. Directories. Command line. dir means directory. Directory folder both are same. See test. See D drive. Yes, sorry. D drive mn Python. See D drive mn Advanced Java, mn AWS, mn Hadoop, mn Java, mn Linux, Oracle, Personal. Yes, all these are folders, right? MS starting with mn all these are folders. Same thing in character interface. See this mn dir means directory. Yes, mn Advanced Java directory. Yes, mn AWS directory. Yes, Hadoop directory. Java directory. All are directories. Directories folders both are same. Yes, in GUI calling as folder. In GUI it's a folder. In GUI it's a folder. Next in character interface it's a directory. Directory is similar to folder. Directory is similar to folder. Directory folder both are same. Directory both are same here. So as per character interface calling as directory, terminology difference here. In character interface calling as directory. Yes, in graphical interface calling as folder. That's it here. Okay. Now D drive, mn Python. Yes, in this folder the test.py file is available. Okay. CLS clear screen. dir output here. Yes, test directory. CD test. Change to test. CLS clear screen. dir. Okay. Yes. Test directory. Right. Yes. Suppose I can go to parent cd double dots CLS like this. Now, what is our requirements? Python directory. mn Python. We should go to mn Python. Yes, same cd command. Change of directory. mn Python. CD means change of directory. Change of directory. Yes, mn hyphen. Yes, mn hyphen Python. Python. Okay, right? Yes, changed. CLS. So Python, yes, we are at Python directory, Python folder, its contents. All these contents here, its contents. Now test.py file, test.py. Yes, notepad, test.py. That Python, Python script. Here this is Python script. See this. Yes, what is this script here? Yes, adding two numbers, subtracting two numbers, multiplication of two numbers, addition, subtraction, multiplication. A equal to 10, B equal to 20, C equal to A plus B, that means 30. Additional value is 30. C equal to A minus B, subtraction minus 10. C equal to A into B, multiplication 200x. So this is script, Python script. Okay, exit. No, Python script, Python. Yes, Python test.py, directly running script. Directly just running script. You can directly running script here. Directly running script. Yes, no error checking, nothing. Suppose if it is C program, yes, suppose C program, first of all you have to compile, checking for errors. In C language, you have to check for errors. C++ checking for errors. First of all, checking for errors means compilation process. Compilation process, checking for syntactical errors and all this, right? If no errors, then running C program. But in Python, yes, no errors checking, directly submission. Directly submission here. Yes, Python, it's a Python interpreter. Python interpreter working on test.py file. Python interpreter just working on test.py file. So Python interpreter, yes, directly executed. The source code executed directly. No errors checking, nothing here. Directly execution. Program executing directly here. Program executed directly here. Directly execution. Source code executed directly here. Source code executed directly. Suppose there are some mistakes. For example, there are some mistakes. Suppose in program, some mistakes. Yes. Suppose here comma missing. For example, suppose here bracket missing. Okay. Suppose here this double quote is missing. Something missing. Okay. Totally three errors. Here three locations, three errors. Now save, control yes, notepad, control yes, save and exit. Save exit. After that, now run it. Yes, Python. Yes, test.py. Just run it. Yes. See, this is error message. Seventh line error. So what's happened here? Only one error showed here. Next error not showed. So what's happened here? What's happened here? See, this statement checked. No error. So executed means memory allocated for A and stored 10. B equal 20. This statement also executed. Memory allocated for B and storing 20 here. So this statement, the checking, error checking completed, execution also completed. This also completed. This also no error. A plus B, no error. Okay. So this also execution completed. ASB calculation is done and stored into C here. While displaying here, got the error. Simply stop. Yes, once error comes, simply stop. So this is working of interpreter. Suppose if it is compiled, what happens here? First checking for all errors from top to bottom. First statement correct, next statement correct, next statement correct, next statement. This is all something error at some line. After checking for the statement, checking for the statement. Yes, here also. Next second error. It shows second error. Compile shows second error also. Next. So compile shows all the errors from top to bottom. Yes, compiler shows all the errors from top to bottom. So compiler shows all the errors. But interpreter, yes, if any error comes, simply stops. Interpreter, if any error comes, simply stops. Okay, stop it, right? Now, let us correct that mistake. Correction of this mistake. Correction of mistake. After correcting, now let us run this again here. Run it. Yes, next error. That means only one error showing 11th line error here. Now correction of the statements. Correction of the statements. Correction of the statements. So this is here missing, right? Save. Only one error showing. It's not showing all the errors. Only one error. That means any error comes to be stopping here. Yes, see this. 16th line error. Here something missing here. So next error, only one error is showing only one error. So next error, either 16th line. So here, this is bracket missing, this double quotation missing, right? Double quotation missing. Save. Yes. Now exit here. Yes. Now run it here. Run it. Yes, it's working fine. So this is working of interpreter. See, let me explain very clearly how interpreter is working here. How interpreter is working. How interpreter is working. Yes. How interpreter is working. See, interpreter. Suppose this is Python source code. First line, next line, next line, next line. There are some lines in Python script. Next, next. There are some lines in Python script. Let us. This is Python script. Suppose this is Python script. How it's working here? Yes, interpreter, Python interpreter. Python interpreter or any interpreter working is same. Interpreter, Linux shell scripting interpreter. Next, HTML interpreter or Perl scripting interpreter. Any interpreter working is same. Yes, here interpreter check for the first statement. Suppose first statement is correct. First its syntax is correct. Syntax means some rules. Like see syntax. Syntax means yes, where to start, where to end. So opening, ending. Yes, open bracket, ending bracket required. Yes, open double quotation, close double quotation. Next, comma required. There are some rules. For print, some rules. Next, this is for some rules. There are some rules here. That's nothing but syntax. Syntax means language rules. Syntax, language rules. See, English language also there are some rules, right? Like active voice, passive voice, present tense, future tense. Fast, there are some rules. Same. There are some rules here. Okay, syntax means rules. That language rules. Okay, you are checking for the syntax of the first statements. Suppose syntax is correct. Suppose syntax is correct here. Syntax. First statement syntax is correct. Yes, syntax is correct. Yes, immediately converts into binary code. This statement converts into binary code. This statement converts into binary code. Zeros, ones formats. After that, yes, this is given to processor. This is given to processor. So processor taking the binary code executes, generating output here. Yes, first statement completed. See, first statement checking. Yes, if it is correct, immediately converts into binary codes, generating output here. See, next coming statement may be right or wrong. Interpreter never think about next coming statements. Interpreter never think about next coming statements. Next coming statements may be right or wrong. Never think about next coming statements. Yes, if the statement is correct, yes, immediately converts into binary codes. So first line converted executed means first line completed. Sorry. First line, 1 second. Let me have some water. Yes. So next, yes, checking for next statement. Checking for next statement. Suppose next statement also correct. Same. Converts into binary code. Zeros, ones format. Okay. Just given to processor. Generating output. Generating output. Yes. Checking for next statements. Suppose something wrong here. Stops. Error at some line shows error message stops. That's it. This is working of interpreter. Yes, checking first line. Yes, correct. Execution is completed. Checking the execution of first line completed. Next statement. Next also correct. Completed. It's line by line. First line checking done. Yes, execution is completed. Second line checking then execution. Third line something wrong. Simply stops. Any error comes. Simply stops. It shows only one error message. Interpreter shows only one error. This is working of interpreter. How correct? Suppose if it is compiler, how compiler working? About compiler. Let us say about compiler. How compiler is working? Let us say about compiler. Compiler. Yes, how compiler working? Compiler. For this, for example, let us take C language source code. Suppose test.c program. Test.c program. How it works? Test.c program. Checking first statement. Suppose first statement is correct. Yes, even correct. No, it won't convert into binary code. No, immediately won't convert. Checking for second statement. Second statement also correct. No, it won't convert into binary code. It won't convert. Okay, checking first statement correct. Checking next statement correct. Checking next statement. Suppose something wrong. It shows error at some line here. Error at some line. After that, error at some third line here. Yes, checking next statement also. Okay, next checking next statement. Okay, like this top two part of checking all the statements. Suppose something wrong here, error at some line here. So second error. It shows second error also. Next error, next error. So next error. So next error. Like this top to bottom. Suppose something wrong. Here are this error, right? So next error. So next like this. Like this. Top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Compiler checks whole program from top to bottom, but interpreter is only one line checking. If any error comes, simply stopping there only. It won't go to next line here. Okay. Yes, once error comes, interpreter stops. Once error comes, interpreter stops. Practically showed that is. Practically discussed, right? Yes, any error comes, interpreter stops. But compiler is not like that. Top to bottom, checking all the statements from top to bottom and shows all the errors. Just it shows all the errors. It shows all the errors. Now, correct. As a programmer, you have to correct all the mistakes here. As a programmer, correction of mistakes. As a programmer, correct all the mistakes. Okay. After correction, recompile. Yes, you have to recompile. Suppose next time, correct. Okay. Yes. Next time, this also correct. Next time, this also correct. Okay. So everything is correct. From top to bottom, everything is fine. No errors. No comparison errors. If no errors, then what happens? If no errors, then compiler opens another file. Then compiler opens another file. If no errors, then compiler opens another file here. Compiler opening another file. After opening another file here, compiler opens another file. After opening another file here, this whole code converts in binary formats. All the statements, zeros, ones formats, zeros, ones formats. All the statements converts in binary codes. All the statements, every statement, or top to bottom, all the statements converts in binary format. All the statements converts in binary formats. Yes, every statement, top to bottom. Yes, this also show practically. Yes, compile the case also will see practically. All the statements, yes, converts into binary codes and write to another file. This file called as exe file. This file called as exe file. Generating some exe file. Yet this exe name may be test.exe file. The test.exe file, then test.c converting to test.exe file. Okay, if no errors from top to bottom, whole program converts into binary code and write to another file. Write to another file means exe file. Exe file. Exe means executable file. Exe means executable. 1 second. 1 second. 1 second. This guy, Anil. Yes, has to rejoin. Yes, he is facing some, has to rejoin into session. Okay, now it's okay, fine. Okay, yes. So generating test.exe file, right? This exe file, yes, submitted to processor. So processor taking that exe file, executing, generating outputs. So at a time, complete output getting here. So previously, first line check interpreter checking first line, getting output of first line, checking second line, getting output of second line. So next something error simply stopping. But compile is not like that here. All the statements checking no error, generating exe file. All the statements at a time executes, at a time giving output here. So generating exe file. Okay, this is main difference between compile and interpreter. Yes, compiler generates one exe file. That exe file. Compiler generating one exe file. That exe file submitter. Processor taking exe file, then executes. That's finally generating output. At a time giving output. Yes, let us see practically one example. Compiler also. Suppose C programming in Linux. Yes, in real time, C is always Linux based. Yes, no Windows based C programming in real time. Windows based C programming only learning purpose. Maybe in your school or college, learning C language. In college, learning C language. That case we can use Windows based. But real time application all about Linux based. Yeah, Linux based. Okay. Yes. This is Linux based. This is a Ubuntu Linux. Linux based. ls list of files cd mn route directory. Yes, yes, you guys don't worry about it. Yes, Linux. Yes, don't think about Linux base. Okay. Yes, yes, so I'm using some commands like pwd command, cw command, yes, cd command, ls. Don't think about these commands. That is not our topic here. Linux is not our topic. Okay. Yes, compare a topic, compare a topic. Okay, try to understand about compiler. That's it. Don't think about Linux base. Yes, on Linux, how to develop Java applications, that also we'll discuss. Yes, we have separate session on Linux base. Okay, Linux. Yes, Linux classes. I'll take 2 classes on Linux base. Yes, on Linux base, how to develop Java applications, that also we'll discuss. Okay. Yes, remove. Star all the files were removed. Yes, no files. Prachin working directory mn route ls no files. Okay, now gedit. Gedit is like a notepad, Windows notepad. Gedit. Gedit is editor. It's editor. Graphical editor. Graphical editor. Like a notepad. Like notepads. Test.c program. Okay. Yes, in this hash. Yes, hash includes stdio.h. Okay. Next, white main function. White main function. Yes, starting, ending. Yes, same. Yes, addition, subtraction, and multiplication. Same program I'm explaining here also. Same program here also. Addition, subtraction, multiplication. Same programs. Same programs. Okay. Yes, int c is equal to 10. Okay. Next, sorry, int a. So int a equal to 10. Yes. Next, int b is equal to 20. Int a b. Next, int c just declare. Next, c equal to yes a plus b. A plus b. Okay. Printf. 1 second. Let me maximize this font size. Changing font size. Yes. So printf. Yes. Addition equal to yes personally comma yes slash n. We'll take next line displaying c value. So this addition subtraction, next multiplication. Yes, c equal to a plus b, c equal to a minus b. Subtraction. Okay. Yes, this thing C value. C equal to A into B. Yes, multiplication. Multiplication. Yes, multiplication. Multiplication. Addition, subtraction, and multiplication. Okay. Yes. Save. Control yes, saved here. So A equal to 10, B equal to 20. First addition. So addition value distinct. Okay, fine. C equal to A minus B. Subtraction. Fine. C equal to A into B. Multiplication. Fine. Save and close. After ls, see test.c file. Like a Python script here, test.c file. Now this test.c file you can't execute directly. You have to compile it. First you have to compile it. GCC -c test.c compilation. I'm compiling. Okay. First we should compile it. Yeah, sorry, a little bit. I'm suffering from cold. That's the reason a little bit some voice, some getting differently. Suffering from cold. Yes. Yes, GCC -c. C means compilation process. Just only compilation. Test.c compiling. Yes, compile, no error. No error. Okay, if no error, what is next step? GCC -o. Yes, project. Yes, that exe name. Test. Now this test.c file generated one test.o file. Now this test.o file is converting into exe file. Result exe is projects. Yes, exe file generated. Project exe file. Okay, so test.c. Yes, no errors. Finally converted to project exe file. The test.c. Finally, it's a project exe. Yes, that exe name can be anyone, no issue here. You can give any name here. Not only projects. This name can be anyone here. Project exe file. Project exe file. The green color in Linux, green color means that is exe file. Now execution of exe. Yes, project. That exe submit to OS. OS taking exe file and yes, it will given to processor. Everything by the OS. Yesterday we discussed every request goes to OS only here. No OS. Linux OS taking that project exe file and passing to processor. It will pass to processor. Linux OS taking project exe file here, simply giving to processor. Now processor will execute and generating out. Generating outputs. Yes. Now let us see that contents of project file. The project exe file. Exe contents. Exe file. Yes. Let us see exe file. So what is exe file? Exe file is a binary code file. Exe file is a binary code, means system understandable language, zeros ones format. See this exe file. See this exe file. Exe file contains completely binary code, right? That exe file contains completely binary code, zeros ones format. See that binary code. This is machine language. It's a machine language. We can't understand this one here. It's a system understandable language. It's a system understandable language. It's a processor understandable language. We can't understand this one here. It's a system understandable language. Okay, that project exe file. So that project exe file executed and generate output. So what was happened here? What is happened here? So test.c file, no errors. Finally converted into exe file. That exe file executed. Okay. Now, yes, let us see some errors here. Yes, let us see some errors. Suppose some errors in the C program. Gread test.c. Let us make some mistakes here. Suppose the semicolon missing. Okay. Here suppose something here missing. Okay. Suppose here double quotation is missing. Suppose here semicolon missing. Here comma missing. Okay. Next here bracket missing. So then yes, many yes mistakes, right? There are many errors. Save. After saving, now let us compile ls test.c file. Let us compile gcc-c test.c. Yes, see this. All the errors from top to bottom. See 8th line error, 10th line error, 12th line error, next 14th line error. Yes, next 25th line error. Yes, it's showing all the errors from top to bottom. Same, what I explained here. Okay, compiler shows all the errors from top to bottom. Compiler checks the all statement from top to what shows all the errors. See that? All errors. All the errors. 8th line error, 10th line error, 12th line error, 14th line error, next 25th line error. All the errors. Compiler checks whole program from top to bottom. Compiler checks whole program top to bottom and shows all the errors. And shows all the errors. Okay. Now let us correct mistakes here. Mistakes. Suppose first error. Here this is mistake, right? Second error. This is mistake. Okay. Next somewhere here error. Okay. Some mistakes were corrected. After correction. Now let us recompile. Let us recompile. Yes. All statements not corrected here. Yes. Let us recompile. Yes. Still error message. Still showing all the errors. Still all the errors. 14th line, 25th line. Yes. Again errors here. Now let us compile again. Let us check it here. Yes. So this is semicolon here missing. Okay, here. Yes. Here bracket missing. Right? Save and close. Sorry. Here control is clear. Same. Yes. LS. Yes. GCC hyphen C test.c compiling. Yes. Still error message. 14th line. Okay. 14th line error message. Reads. Yes, 40. So this is double quote, missing this double quote. This error message. Save and close. Control L screen clearing. GCC, yes, no error. Test.o file generated. After that, GCC hyphen C projects. Okay, test.o. Test.o file. Yes. Hyphen C, not C, hyphen O. Hyphen O. Yes, the project exe file generated. Yes. Dot slash project exe file. Yes. This is all my experience. Yes, I worked in C language, embedded C. I worked in Python, worked in Java, worked in Linux. All that my related experience. 23 years of experience. Lot of skills. Okay. Yes. LS. Yes. The project exe file executed. Right? Project exe file executed. So this is about compiler. Okay. Yes. Let us see the differences here. Let me compare this so then easy to understand for you. Points wise. Let us compare this points wise here. Points wise. Yes, interpreter and compiler. Yes. Yes, interpreter. Yes, interpreter. Interpreter versus compiler. Yes. Interpreter and compiler. What's the difference between these two here? See. First point. Yes, interpreter, first point. How interpreter working here? Yes. Interpreter. Yes, it checks the codes. It checks the codes line by line. Line by line. Means first line checking. If first line is correct, immediately execution. Only one line checking. Next line checking, correct, immediately execution. But compile is not like that. Compile is not like that. Compiler, it checks whole code from top to bottom. Top to bottom. Yes, that we discussed practically. Okay, practically explain here. It's a practically we discussed. Okay. Yes, interpreter, it checks the code line by line. Yes, compiler, it checks whole code from top to bottom. Okay, right? Next, output, when come to output here, it generates. Yes, it generates. It generates. It generates output. It generates output. It generates output line by line. Line by line. Line by line output here. Line by line outputs. Line by line output here. Line by line. What's compiler? Exe file, right? That exe file executing directly, generating output at a time here. So this is at a time output here. At a time output. At a time output here. It's at a time output. At a time output here. So at a time. Okay. So top to bottom executing at a time and giving outputs. Okay. Yes. So at a time getting output here. But interpreter is line by line. Okay. Next. Yes. Interpreter. If any error comes, simply stop, right? Yes, it shows only one error It shows only one error. It shows only one error. Okay. Compiler, yes, it shows all the errors, all the errors from, yes, top to bottom, from top to bottom. It shows all the errors from top to bottom. It shows all the errors. Okay. So interpreter shows only one error, but compiler it shows all errors. It shows all errors from top to bottom. Okay. Next. Main difference between interpreter and compiler. So main difference, exe file. Main difference is exe file. Yes, it does not generate exe file. Compiler, interpreter does not. It does not generate. It does not generate exe file. It does not generate. It does not generate exe file. Exe file. Compiler, it generates. It generates. It generates exe file. This is main difference. What's the main difference between interpreter and compiler? Yeah, this is interview questions for freshers. For experience may not be asking, but freshers, interpreter compiler difference. Main difference is exe file. Main difference is exe file. Interpreter does not generate exe file. See, what's the difference between interpreter and compiler means? Interpreter working is line by line, compiler whole program at a time. Next, immediately you should say exe file. Interpreter does not generate exe file, compiler generates exe file. Compiler generates exe file. See previously, yes, interpreter case. See Python can directly execute it, right? No exe file generated. The test.py file, Python script executed directly here. But what's happened in C language? One exe file generated, project exe file generated. That exe file executed. Okay, right? Yes, in case of here interpreter case, in case of interpreter here, yes, it executes source code directly here. Yes, it executes interpreter. Yes, it executes source code directly. Source code directly here. It executes source code directly. But compiler, yes, it executes exe file, not source code. It executes exe file. It executes exe. So interpreter, it executes source code directly. Interpreter, it executes source code directly. Yes, compiler, it executes exe file. Exe file. So this is main, these 4 and 5 main differences, main important differences. Interpreter, it does not generate exe file. It executes source code directly here. Compiler generates one exe file and executes. Generating exe file and executing. Okay. Yes. See, interpreter based languages are called scripting languages. Scripting. They are scripting languages. Scripting languages. Scripting language. Scripting means that can be modified anytime. Scripting means that can be modified anytime. The script means that can be modified anytime. The script can be modified at any time here. So script can be modified at any time here. Okay, at any time. Yes. Compiler, they are programming languages. Programming language. They are programming languages. They are programming languages. They are programming languages. Okay. So interpreter, all scripting languages are interpreter based language. Scripting languages are interpreter based language. Programming languages are compiler based. Okay. Scripting language examples. Best example is Python. Python. Next, Linux shell. Linux shell scripting. Linux. Yes. 1 second. CD double dots. Yes. ls. Yes. Here don't have script here. Let me develop small script. Grit. Suppose math.sh. Shell script. See a equal to 10. Same. Yes. B equal to 20 here. Yes. Echo. Yes. Addition value is equal to here. Yes. expr $a plus $b. Okay. Yes. So this is addition. Next, subtraction. Next, multiplication. Addition, subtraction. Yes. A minus b. Next, multiplication. Multiplication equal to, yes, backslash star. Yes. Addition, subtraction, multiplication. Okay, yes, save. Simple script this is. Okay, yes, see this math data sets. That shell script sh means shell script here. Here this script executing directly, no comparison, nothing, directly execution like a Python. Yes, like a Python. Yes, here also the script executing directly bash. Yes, addition, subtraction, and multiplication. See this. Let us make some mistake. Yes, see this. Here directly executing here, directly running here, script running directly here. Okay, script running directly. Okay, yes, script running directly here, script running directly. Suppose some mistake. Suppose addition is okay. Subtraction here, let us make some mistake here. Some mistake. Save and run it. See this. Addition equal 30 display, right? Next error comes stop, right? So what's happening here? Interpreter, how it's working here? Interpreter. Yes, A equal to 10. This statement checked and executed. Means memory allocate for A stored 10 here. Next statement checked. Statement is correct. Memory allocate for B also. So memory allocation for A, memory allocation for B, storing 10 and 20. After that, addition. This also executed. Addition. This also executed. See that. Addition. Addition equal 30. Means checking then execution. First statement checked, convert into binary codes, then executed. Second statement checked, convert into binary code, executed. Next statement checked, convert into binary codes, yes, executed. After this execution result also we got it here, line by line. First line checking, executed. Second line checking, executed. Third line checking, executed. So checking syntax correct, output got it. Now here some error. Simply stop, correct, error. Line name, error, that's it. Any error can simply stop, that's it. So this is the interpreter. This is the interpreter. So shell, yes. So interpreter, now correct that mistake here. Just the correction of that mistake. Yes, here. Yes, some quotation is missing here. Okay. Now run it. Yes, directly execute it. No exe file concept here also. No exe file. No exe file. Let us take one more example here. No exe file. So Python script, no exe. No exe file. Shell script, no exe file. Similarly, HTML. Hypertext markup language. HTML. Let us go to HTML example here. Suppose advanced Java HTML folder. Here the HTML file is there. Suppose from HTML. One second. The actual login form. Login. See, this is login form. This is source code. HTML source code. This source code. User ID, passwords, submit and reset. It's login form. See, this is directly executing. Just double click and run it. Double click and run it. Opening the browser. Opening in the browser. Yes. Directly form got it. Login form got it. Okay. Yes. Reset. Reset it initial values. Okay. Submit. Submitting. Okay, right? Yes. So this is HTML. That HTML browser is an interpreter for the HTML. Yes, HTML is a browser understandable language. HTML is a browser understandable language. Browser only can understand. Browser is an interpreter. Browser is an interpreter for the HTML. So HTML. So HTML. So hypertext markup language. So Python scripting, shell scripting. Yes, HTML. Yes, suppose PHP scripting. Next Perl scripting. So there are different scripts like this. There are different scripts. Okay. Yet these scripts executes directly here. In scripts, no exe file concept, directly executes. Okay, in scripts here, all scripts executes here. No exe file concept. Okay, yes. Next, programming language examples. Examples here, C language, C language. Okay, C++, .NET C hash. These are programming languages. They're compiler based. C, C++, .NET C Sharp. These are the compiler based languages. Just now we have discussed how C compiler is working. How C compiler is working just now discussed, right? Okay, they're compiler based. Okay, yes, these are scripting language. See, if it is scripting language that can be modified anytime. Scripting language can be modified. Scripting means that can be modified anytime, but programming can't modify it. See, programming. Suppose in programming here, programming. 1 second. 1 second. In programming, yes. See, once exe file generated, that exe code you cannot modify. That exe project exe file generated, that exe file you cannot modify. We can't modify. We can't modify the exe file. Once exe file converted here, once you convert the exe file, you cannot modify. But scripting can be modified anytime. That Python script, open Python script here, open Python script and modify anytime. Suppose I don't want modification, just removing, save and exit. Next run it here. Yes, anytime you can. That's nothing but scripting. Scripting means it can be modified anytime. Scripting means it's a open source. Scripting is always open source. It can be modified anytime. Open source means that can be modified anytime. Open source means that can be modified anytime. But programming is not a open source. You can't modify this. Okay. Yes. Next. Yes. Here. So next here. Yes, interpreter based language. Interpreter. Yes, interpreter. Interpreter based language. Based language. Don't have. Yes, don't have exe file concept. 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 Here everything is exe file. Compile based. Everything is an exe file. Everything is in exe file. That's the difference. Okay. Yes, next here. Yes, interpreter based. Yes, it is an open source. Scripting. It's an open source. 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 It can be modified. It can be modified. Modified anytime. Yes, anytime. At any time it can be modified. It can be modified anytime. Yes. Yes. It's a closed source. It's a closed source. We cannot. It's a closed source. Okay, it cannot be modified. It cannot be. Once build is created, it cannot be modified. It cannot be modified. Okay, so these are the differences. Same thing explain document also. See the document, this is documents. In document, same 9 points explained very clearly. Same. 1 second. See, difference between compiler interpreter. Interpreter compiler. See that first one. Interprets code line by line and executes at a time. Compiles at a time. Yes, interpreter giving result line by line. Compiles whole output at a time. Okay. Next. If any error occurs, interpreter stops. Means it shows only one error. It checks all the statements from top to bottom and shows all the errors. Next, interpreter, it will not generate executable file. Compiler generates executable file. Yes, it always executes source code. Interpreter always executes source codes. Compiler, it executes exe file. Yes, these are all are scripting languages such as HTML, Perl scripting, these things. These are programming languages. Okay. See, interpreter based language don't have exe file concepts. Interpreter based language don't have exe file concepts. This is very, very important point. Remember this. Interpreter based language don't have exe file. Okay. Yes, next here every program converts in exe file. Exe file. Next, here it's open source. It can be modified anytime. Yes, it's not an open source, it's a closed source. You see, exe based. It's exe based. It cannot be modified. It cannot be modified. It cannot be modified. Now here doubt here. Yes, many are guys saying the maybe some doubts. Yet this trainer is explaining about all but not explaining about Java. Yes. Yes, that's a $1 million question from your side. Okay. Yes, somebody is thinking about it. Yes, this trainer is explaining about all that. But what is Java? Java comes from what? What is Java? Yes. Is it interpreter based or compiler based? What is Java? Is it interpreter based or compiler based? Yes, that you have to decide now. I'll explain about Java, then you decide. After explanation, How is Java working? I will explain. After explanation, you have to answer question. Okay. Yes. Yes. Interpreter. No. Interpreter is who is dependent. It's not same. Interpreter is who is dependent. Okay. Interpreter is who is dependent. It's not same. Python interpreter for Windows OS. Python interpreter for Linux OS. Python interpreter for Mac OS. Python interpreter for Unix OS. That interpreter changes from OS to OS. Interpreter is not same. Okay, even compiler also changes. Interpreter, compiler, all these are OS dependent. OS dependent, not same. Interpreters, compilers are OS dependent. See, suppose Python software downloaded for the Windows OS. Same software you cannot install on Linux OS. Okay. Yes, Python software for Windows is different, Linux is different, Mac is different. Okay. Yes, compiler. C compiler for Windows OS is different, Linux OS different, Unix OS different here. Separate compiler you have to download it. Separate softwares you have to download it. That's OS dependent. Okay. Yes. Yes. About independent and dependent, the topic we'll discuss now. Today topic on that is we'll discuss now. Okay. Yes. So now let us come to Java. Let us come to Java. What is Java? Yes, I will explain about Java. I will explain how Java is working. I'll explain about Java. You decide it finally. Finally, you decide it. Okay. See, except Java. See, except Java. Except Java means other languages. Other languages. In other languages, what happens here? So first of all, yes, other languages. Other languages. First of all, source code. First of all, source codes converts into binary codes. Source code converts into binary codes. Binary codes. Source code converts into binary codes. Just now we discussed same. Interpreter compare examples. Source code converted into binary codes. Yet that binary codes given to processor. Binary code given to processor. So processor taking that code here. Okay, yeah. Binary code is different, byte code is different. Binary code is different, byte code is different. Binary code is a system understandable language, processor understandable language. Byte code is a JVM understandable language. Now we'll discuss just a minute. Just only 1 minute. Source code converts into binary code. That binary code given to processor. Binary code means zeros ones formats. Binary codes. Binary code is like this. Binary codes. Binary code is like this. Binary code is in zeros ones format. It's a binary code. That's called binary code. Binary code is different. Byte code is different here. Source code converts into binary code. That binary code given to processor generating output. So this is a case of other languages. Other languages. Other language. What is happening here? Okay. Source code to binary code. Yes, source code to binary codes. That conversion. Source code to binary code conversion. Conversion by the compiler or interpreter. Either compiler or interpreter. Only one thing is working. Either compiler or interpreter. Suppose Python interpreter involving, C language compiler involving, C++ compiler. Suppose Linux shell scripting. In that case, interpreter involving only one thing. Yes, let us come to Java. Yes, what happens in Java here? Let us see about Java here. Yes, what happens in Java here? Java. Yes, in Java. So first of all, yes, source codes. First of all, source codes converts into byte codes. Converts into byte codes. Source code converts into byte codes. After converting into byte code here, that byte codes again convert to binary codes. Binary codes. Binary codes. That binary codes given to processor. Given to processor. Given to processor. Then finally generating outputs. Okay. Yes. There is an intermediate code introduced in Java. Some byte code introduced. Intermediate codes. Intermediate codes. Intermediate code is introduced in Java. Byte codes. Why byte code introduced in Java? To make the Java as independent platform. Okay. Why byte code introduced in Java? Why byte code? To make the Java as independent platform. To make Java as independent platform. Yes, we'll discuss now. Yes, after finishing, next topic is that only here. Okay. source code to bytecode. Who will convert source code to bytecode? This is by the Java compiler. Java compiler, Java compiler, Java compiler, Java compiler converting source code to bytecodes. Okay, source code to bytecode converting by the Java compiler. Let us see that example also. Suppose D drive, CD backslash D drive CLS DR. Suppose in D drive, some test folder. Here they say test.java file. Okay, some test.java file. CD test folder CLS. DR. Here they say test.java file. Notepad test.java. This is test.java. So this is Java program file. Public class test. Public static void main string area funcs. System.out.println. Okay, suppose here it's a hello world program. Just hello world program. Save. Control save and exit. Yes, for understanding purpose, I'm showing notepads, but actually we'll be working on Eclipse. Java Eclipse. Every day using Eclipse, no notepads. Notepad never using real time. Eclipse only completely. I'll be explaining on Eclipse. Don't think about notepads. Never have notepads here. I'll be using Eclipse. Okay. Yes, now I'm compiling Java C. One second. Just a minute. 1 second. DR CLS DR. Yes, here dot class. Del dot class. Star means all. A star dot class file means all the files ending with dot class. All the files extension dot class. Del means deletion. Deletion of all files. Star means all. All files extension dot class. Deleting dot class files. Yes, deleted. Okay, DR. Okay, now test.java file is there. Test.java file is there. Okay, now. So this is notepad. 1 second, notepad test.java. So this is your Java program. So this is Java program. Okay. Yes, Java program. Yes, Java C compilation. Java C means Java compiler. Now you get Java compiler is working here. Test.java. Yes, compiled. DR. C. No error message generating dot file. Okay. So what happens here? Yes, source code converting to bytecodes by the Java compiler. See here, Java compiler. See Java, yes, Java compiler. Checks for all errors. All errors from top to bottom. Okay. Yes, Java compiler checks for all errors from top to Java compiler checks for all errors from top to bottom. Okay, if no errors, then it generates bytecode file, not exe file. Suppose if C language compiler, if no errors generating exe file. In C language, if no errors generating exe file, that exe file contains binary code. C language exe file contains binary codes. But in Java, what happens? Not exe file. Yes, here Java compiler checks for all the errors. Okay, if no errors, then it generates bytecode file called as dot class. It's a dot class file. Bytecode file is a dot class file. Okay, so bytecode, this is source code is converting into bytecodes by the Java compiler. Source code converting into bytecode by the Java compiler. So this is compiler. So bytecode for dot class file generated. Okay, dot class file generated. Okay, yes, next after this. Now this dot class file. Yes, now this dot class file execution. Yes, Java test enter key. Yes, executed. Yes, which one executed? It's interpreter. See, the Java C means compiler. This is what Java interpreter. Actually, it's a JVM. It's a JVM. Java means JVM. As a part of JVM, this is the interpreter. Interpreter taking tested dot class file, converting into binary formats and execution. So program interpreter. Error checking by the compiler, but program execution by the interpreter. Okay. Yes. See, source code converted into binary code, byte code. Source code converted into byte code by the Java compiler. Next, byte code converting into binary codes. The byte code converting into binary codes. This is by the Java interpreter, Java interpreter, Java interpreter, interpreter. So interpreter, right? Interpreter. Okay, right? Yes, interpreter. Source code to byte codes by the compiler here. Byte code to binary code by the Java interpreter. So Java compiler checks for all errors from top to bottom. If no errors, generating dot class file, right? Okay. Yes, runtime. Yes, Java program runtime execution. Yes, Java runtime. Java runtime. Yes, Java runtime execution. Yes, execution by the interpreter, by the interpreter, by the interpreter, by the interpreter. Execution by the interpreter. Java program execution by the interpreter. Okay, program execution by the interpreter. Error checking by the compiler. If no errors, generating on byte code file here. That byte code file is executing by the interpreter. Executing by the interpreter. Okay, so here, so compilation process. Compilation process, checking errors by the compiler. Runtime process. Runtime program execution by the interpreter. So what is happening here? Suppose test.java. Test.java is a source code, right? This is source code. Test.java is source code. Suppose source code. That source code, right? That source code given to Java C compiler. Java C. C test.java. Java C test.java. Okay, right? Yes, error checking with the compiler. Test.java given to Java compiler. Java compiler taking test.java. So the test.java given to Java C compiler. Yes, if no errors, generating. Yes, generating what? Tested dot class file generated. It's a byte code. It's a byte code file. So byte code file generated. Byte code file generated. After generating byte code file here, byte code file, the tested dot class file generated. Now Java test running. Now here interpreter. Yes, runtime interpreter working here. Now tested dot class file. Tested dot class file. Byte codes. This is given to Java interpreter. Now it's this interpreter. Yes, interpreter. Interpreter. Given to Java interpreter. It's interpreter. So given to Java interpreter. Java C means Java compiler. Java interpreter. Java it's interpreter. Okay. Given to interpreter here. Now interpreter taking this byte codes. Okay. Interpreter taking byte codes. How interpreter working? Line by line. Java program runtime is line by line. Taking first line from the byte codes. From the byte code file. Taking first line. Converts into binary code now here. Binary code. Converts into binary code. That byte code file is given to interpreter. Byte code file is given to interpreter. So interpreter taking byte code file, converting line by line into binary codes. First line converting to binary codes here. After converting to binary codes, yes, given to processor, given to processor, given to processor. So processor generating outputs. Next, taking second statement, converting into binary codes, taking second statement, converting into binary code, then executing. Third statement, converting into binary code, execution. Third, next statement like this. So line by line, converting into binary code, then execution, right? So what is happening here? Yes, in this process here, in this process, see what you have searched. Tested dot Java file have searched. Tested dot class file have searched, right? Yes, test dot Java file. Okay. Yes, Java interpreter means JVM. Yes, as a part of JVM, this is the interpreter. JVM topic we'll discuss. I'll explain. Yes, as a part of JVM, this is the interpreter. See JVM. 1 second. Actual JVM, Java virtual machine. 1 second. Java virtual machine. Yeah, this is JVM, Java Virtual Machine. This whole thing is called Java Virtual JVM. As a part of JVM, this is interpreter, Java interpreter. Okay, interpreter takes care of execution. This is complete JVM. This is complete JVM. In that, this is interpreter. Yes, interpreter takes care of execution. Interpreter takes care of execution. Okay, fine. Yes. Now here. So what is happening here? Yes, in this process here. Yes, in this process, what is object? We got the test.java file. This is a test.java file and test.class file. The test class file executed, right? Yes. Yes. Anyone observed exe file in this? Anyone observed exe file in Java? Yes, in these steps here, in these steps, any exe file observed? Hello. Yes, guys. In this process, test.java, test.class file. Exe file. Is there any exe file? No. No exe file. No exe file observed here. Only .java, .class file. Okay. .java, .class file. That .class file is not exe file. .class is a bytecode file, not exe file. A .class is a bytecode file. It's not exe file. Exe file is different. .class is different. But .class bytecode file. Exe file is a binary code file. Yes, in Java, everything is .class file. Everything is in Java, everything is .class file, not exe file. Okay, fine. Now here. So here, what is happening here? So here, so compiler, yes, compiler checking for all errors from top to bottom. If no error, generating .class file here. Yes, runtime execution by the interpreter. Okay, right? No, Java depends on what? Java based on what here? Is it interpreter based or compiler based? Tell me. Java depends on what? Suppose here Python interpreter dependence, C language compiler dependence. Okay, when come to Java depending on what? Come to some conclusion here. As per my explanation, as per this explanation here, what is Java? Is it interpreter based or compiler based or both? Three options: interpreter based, compiler based, or both. There are three options for you. Is it interpreter based, compiler based, or both? Yes, both. Java depends on both here. Java, yes, depends. Java depends on both the compiler, as well as interpreter, as well as interpreter. Okay, as well as interpreter, right? As well as interpreter. Java depending on both. Java depends on both the compiler as well as interpreter. See, error checking by the compiler, runtime by the interpreter. Okay, yes. So in Java, see this same point here, expand here. Yes, error checking. Yes, in Java. See, in Java, yes. See, in Java, errors checking, error checking by the compiler. Compile, right? Okay. Next, runtime means execution. Runtime means execution. Runtime execution. Execution by the interpreter. So two things are involved here. Interpreter. Right? Runtime by the interpreter. Runtime execution by the interpreter. Okay. See, last point in differences, we discussed 8 points. See the 8 points. What is this 8 point here? Yes, interpreter based language don't have exe file. Okay, see, 1 second. Any language, runtime, runtime is an interpreter based. Any language runtime is an interpreter based, don't have exe file concepts. Okay, right? Yes. Now, Java language runtime is an interpreter based. Java language runtime is interpreter based. See, any language runtime is an interpreter based, don't have exe file concept. Any language runtime is an interpreter based, don't have exe file concepts. Java language runtime is an interpreter based. Now, question is, Question is here. Question is, yes, is there any exe file concept in Java? Yes, maybe asking question like this, or asking question like yes, asking some question like yes, can we create exe file in Java? This is maybe asking this question. Yes, most important point. This is answer yes or no. Yes or no. Answer is either yes or no. Tell me, what's your answer? Yes, as per this explanation or discussion about exe file compiler interpreter, more than almost 1.5 hours discussed. More than 1 hour and 15 minutes we discussed. Finally come to some conclusion. Is there any exe file concept in Java? Can we create exe file in Java? Say yes or no. Come on, guys. Even you answered already. Already you answered. Same question repeating again. Already you answered. Already you answered. Okay. Yes. Can we create exe file in Java? See, already question. Yes. See, these are the steps, right? Java program development, comparison and execution. Yes, in this process, anywhere observed exe file. In this process, anywhere observed exe file. No, your answer you said as no. You said no. Okay, right? Yes, your answer no. That time your answer no. Same here also. Yes, is there an exe file concept in Java? Yes, here you answered as no. No, this also no. No, no exe file concept in Java. You can't create. No exe file concept in Java. Okay, suppose exe file concept is there is a platform dependent. Suppose if any exe file concept is there is a platform dependent, but Java is independent platform. Java is independent platform. That point also we'll discuss. Yes, independent platform, that also we'll discuss. Okay, so depending on yes, Java depending on both the compiler as well as interpreter. Java depending on both the compiler as well as interpreter. Next, there is no exe file concept in Java. No exe file concept in Java. Yes, no exe file. Yes, no exe file. Okay. See, since Java, yes, since Java runtime is an interpreter based. Runtime is an interpreter based. Interpreter. Yes, interpreter based. Okay. Since Java runtime is an interpreter based, yes, no exe file concept. Yes, no exe file concept in Java. No exe file concept. No exe file concept in Java. That's the conclusion. Okay. Yes, all the points it's been documented. See documents. Let us go to documents. You guys not required write any running notes. Running notes not necessary. Every topic prepared in documents. See this, all this. Interpreter compile today topic. All that 9 points. Very clearly explain that all 9 points. Explain very clearly. Okay. See, Java depends on both the compiler as well as interpreter. In Java, errors taken by the compiler. Okay, if no errors, then Java compiler generates .class file. Java compiler generates .class file. .class file is a bytecode file. Java runtime by the interpreter. Okay, errors by the compiler, runtime by the interpreter. Same what we discussed. Source code to okay, bytecode to binary codes. Then yes, output getting. See this source code. Two steps. Source to bytecode, byte to binary codes. Also output here. Source to bytecode by the compiler, bytecode to binary code by the interpreter. Java depends on both the compiler as well as interpreter. Java runtime is an interpreter based. Yes, any language runtime is an interpreter based new exe file. Any language runtime is an interpreter based new exe file. Yes, since Java, yes, Java is interpreter based. Since Java runtime is an interpreter based new exe file concept in Java. Yes, question. Can we create exe file in Java? No. Answer is no here. There is no concept of exe file in Java. In Java, everything is .class file, not exe file. Okay. So that's all about interpreter, compare, and all the basics. Now it's about features of Java. Now you can understand these concepts very clearly. Okay. Generally, most of the trainers directly they will explain about independent platform. Yes, that's not easy to understand. Means here they will not explain in depth. Simply they will explain about independent platform. It's independent OS, Java program development running anywhere. Simply they will explain, but complete information, complete details they will not explain. Okay, independent platform. This also I'll explain very clearly. Okay, here to understand independent platform, yes, exfl dot class for differences we have to discuss. Okay, this is half an hour, 15 minutes topic only. Exfl dot class for difference, 15 minutes. After that, yes, go to features of Java. Okay, yes, tomorrow we'll discuss about. Tomorrow this topic will be finishing. After finishing this topic, yes, installing Java. Tomorrow, yes, last half an hour. First 1 hour, this topic, independent platform topic. First 1 hour. Last half an hour, installing Java and Eclipse setup will discuss. Okay, yes, that's all for today. Yes, any doubts? Yes, guys, any doubts? If no doubts, let us wind up session for today. Yes, 1 second. What are the contents of dot? Yes, we'll discuss. I'll explain very, even that point also I'll explain very, very clearly. I'll explain. Okay. Yes, you guys understanding? Yes, we can't edit dot class file. Dot class file cannot be edited. We cannot modify. Dot class file cannot be modified. Okay. Yes, any doubts? Yes, you understanding clearly my way of explanation, my topics. Yes, yes, guys, are you understanding clearly? Or any kind of getting confusion? Are you understanding clearly my way of teaching? Yes, way of teaching and yes, concepts. Fine. Suppose if you have doubts, you can ask me. Just like a friend, you can ask any doubts. Okay. Generally, most of the trainers, yes, they'll be irritated automatically. When you're asking question, they will be getting irritation. But I'll be cool, always cool. Cool in class or anywhere, always. Yes, I feel like a cool, slowly handling every topic. Okay. Yes, any kind of questions you can ask me. No problem, no issue. Yes, anytime, 24/7, anytime you can ask me, I can respond. Okay, no issue here. Yes, not. Yeah, that's all. Yeah, that's all for today. That's all for today. So thank you guys. See you tomorrow. Tomorrow also same link. Tomorrow also same link. No change. See you guys. See you tomorrow. Have a great day. Yes, I'll share this class link. Yes, today's session. Yes, today's session. Yes, today's session link I'll share. You can watch it. Download and watch it. Today's session. I'll share it now. Okay. Yes, by 1 p.m. you can see. Yes, by 1 p.m. you can see. 1 second. Yeah, that's all for today. So thank you guys. See you tomorrow. Yes, yeah, about Word document, I'll share it. Don't worry. I'll share it. Word document also I'll share it. Okay. Thank you. See you tomorrow, guys.